K-means algorithm. The K-means algorithm is one of types of algorithm used in graph clustering. Clustering is an operation that, when a given set of data classifies similar data into groups. In clustering, each group is called a cluster. As you see here, each group of data is called cluster. The basis for similarity varies according to the algorithm, depending on the things like distance between points or their coordinates. The K-means algorithm uses the distance from the center of each cluster to classify the data. As input, we have groups of data sets and we need to decide K-value as well. And what is K-value? K-value means how many clusters we want to find. Now, let's take a look at the algorithm in the action. First, we prepare the data for clustering. Then we decide the number of clusters. Deciding on the number of clusters beforehand is a characteristic of K-means algorithm. For this time, we will use 3 clusters. The 3 cluster points are set in random location. From each data point, we calculate the distance to the nearest cluster center. Each group point is grouped under one of the predetermined clusters. The mean of the data points in each cluster is calculated and the center point of cluster is moved here. Due to this relocation of center points, it's possible that the nearest center point may change for some data points. The shortest distance to the center point are calculated once again and the points are regrouped into clusters. The process of assigning each data point to the cluster and moving the center point to the mean of group repeats until converge of center points has been reached. As you see, every time we are calculating the mean of the data set and we move the center point. And as we move the center point, some data types belong to, for example, green data group can be the member of red data group because the center is moves away from the data group set. And this process is repeated until we reach the converge of the center points. As you see, converge of center points has been reached, so the operation finished. So the clustering is complete. We can see that data points have been appropriately grouped with the other similar data types. Now let's try running the K-means algorithm on the same data with only 3 clusters and see what happens. We set center points randomly and repeat the process of assigning each data point to a cluster and moving the center point to the mean of group until the converge of the center points has been reached. As you see, as we move the center, the data sets belong to red and goes to the data set of blue. And the process will continue like this until converge of center points has been reached. The converge of center point has been reached now. This time 2 groups of data, the left one and the lower one, have been lumped together in one cluster here in blue one. And the race data is grouped in one cluster, which is red here. As you can see, because the number of clusters must be set before the K-means algorithm starts, if the number is not set appropriately, there are times when no significant results can be obtained. There are a number of techniques used to guess the appropriate number of clusters, like analyzing the data beforehand or simply running algorithm multiple times, changing the number of clusters each time. There are many advantages and disadvantages of K-means. Advantages of K-means algorithm. It's easy to implement, and with a large number of variables, K-means may be computationally faster than hierarchical clustering. Disadvantages of K-means algorithm. It is difficult to predict the number of clusters, K-value. Initial seeds have a strong impact on the final result. And the order of the data has impact on the final result. And is sensitive to scale. Rescaling your datasets will completely change